Hi everyone, so today let's take a look at a question on Maclaurin series. So you are given the equation ln 1 plus y equal to tangent x. And part A of the question, you are supposed to show that particular expression. Alright, and for Maclaurin series, usually I wouldn't want to try to make y in terms of x before I start to differentiate. Usually the first derivative is still possible, but subsequent derivative, right, I usually see you will get very complicated. So our preference, right, is actually not express y in terms of the rest, but instead we will make use of some implicit differentiation. So like this case, maybe I will try to attempt to differentiate this directly first with respect to x. So when I differentiate this with respect to x, I get 1 over 1 plus y dy dx equal to secant square x. And usually, again, I wouldn't want to differentiate this without any simplification first because I don't really like this fraction. I don't like this expression. Usually fraction, when you do differentiation, it might involve quotient rule, which will make your expression very complicated. So usually what I will attempt to do, right, is to try to make use of product differentiation instead. So in this case, right, maybe I can just multiply this over to the other side. So dy dx will just be 1 plus y secant square x. I think this is a better equation to differentiate one more time. So let's do it. So differentiate respect to x again. I get d squared y over dx squared. This one I'll use product rule. Maybe I'll keep this first, differentiate this. So I got dy dx secant square x plus 1 plus y. Differentiate this, you will get 2 secant x tangent x. Okay, let's simplify a bit. So dy dx secant square x plus twice 1 plus y secant square x plus tangent x. Alright, so usually when you are doing proving question, right, we have to try to look at the final result that we want to get. Then we will try to stir our direction towards it and not to just randomly do it. So in this case, if I see, right, seems like there's no y involved. So I don't really like this. So maybe I can attempt to try to do a replacement. So let's see where we can do a replacement for this part. I think I see something. That is this expression here. I can see that actually this is the same as dy dx. Right, so we can do a replacement for this part away. So I will get dy dx secant square x plus 2 dy dx tangent x. And finally, I think I will just need to factorize out my dy dx. Then I will be able to get what I need to show. I just swap these two positions to make it in line with what the question wants. So I get 2 tangent x plus secant square x shown. Alright. For part B of the question, say by further differentiation of the result in part A, find the Maclaurin series of y up to including the term in x cubed. So if you want to find the term in x cubed, right, I think no choice. This is the formula in the MF for Maclaurin series. I need to at least differentiate it one more time to get a term with d cubed y over dx cubed before I'm able to find out what is the coefficient of the d cubed y over dx cubed. So let's differentiate this one more time. So I will get, let me just write it down here. So differentiate this, I will get d cubed y over dx cubed. So here I have to make use of product differentiation. So maybe I'll just keep this first, differentiate this. So I get d squared y over dx squared, 2 tangent x plus secant square x. It's pretty long, so maybe I can write in the next line plus. Now I will keep this, differentiate this. So dy dx, differentiate this, I'll get 2 secant square x plus 2 secant x tangent x. Okay, and I think I'm probably not going to simplify this because our final result is to get the value of d cubed y over dx cubed. So there's no point to simplify it, then you sub the value of x equal to 0 inside. So might as well I can just sub it indirectly. We can save a bit of time. Alright, so maybe now we can start to find out all the coefficient for the polynomial. So when x equal to 0, let's find our value of y when x equal to 0. So you sub 0 inside here, then you will be able to get y equal to 0. Okay, and for dy dx, I will be using this expression. This is the easiest. Of course, you can use this, it doesn't matter. So maybe when x equal to 0, secant square 0 is 1. This is the value when y is 0, when x equal to 0. So I will get dy dx equal to 1. Okay, now let's look at my d square y over dx square. So when x equal to 0, this is actually 1, this is 0. And this is the value of dy dx when x equal to 0, so it happen to be 1. So my d square y over dx square, I will get equal to 1. And for d cubed y over dx cubed, this is more complicated. When x equal to 0, maybe I can just write down some of the values here when x equal to 0. So this is 1. So this is 2, this is 0, this is 1 because cosine 0 is 1. So I'll get 1. Okay, this is the value when dy dx when x equal to 0. So this is 1. This is 1. So you get 2 plus this whole thing will be 0. So let's see, when you simplify everything, you should be able to get 3. So this is 3. So once I get this, I can just plug all these values in our expression here. So therefore, my y will just be equal to 1 plus, sorry, it's not 1 plus. Let me just rewrite this because the value of y is 0. So this one will be 0. This one will just be 1. So it's x plus, put 1 inside here. You get x squared over 2. This one you will put 3 inside here. You simplify, you'll be able to get x cubed over 2 plus dot dot dot. Right, so this will be my answer for my part B. Okay, so for part C, you're supposed to find an estimate for the value of E, the exponential term. Okay, maybe I need to use this expression. Let's keep this first. Maybe I need this also. Okay, let me just erase this part. Okay, so from here, maybe I can just try to make y the subject first and see what will I get, because I think I will definitely need the expression for y. So maybe I can just attempt to try to make y the subject first, then we will see what we will get. So here I will get e to the power of tangent x, y equal to e to the power of tangent x minus 1. Oh, okay. At least, right, I managed to see there's an exponential term because the final result wants us to find the value of e. So maybe this, this form will actually works. So I think by a bit of observation, right, I don't really like the tangent x. To really like kind of like get rid of it, right, I will actually sub the value of x to be pi over 4. Because I know, right, tangent power 4 actually give me 1. So if you give me 1, right, you will just left with exponential e to the power 1. And e to the power 1 is what I need to find. So maybe I can just let x to be pi over 4. So when x equal to pi over 4, right, I'll just get y equal to e to the power tangent pi over 4 minus 1. And also, this is an approximate value for y. This is the expression. So if I will be subbing x equal to pi over 4 into here, that means to say I should also sub x equal to pi over 4 into here also. So maybe I can just write pi over 4 plus pi over 4 square over 2 plus pi over 4 cube over 2 plus dot dot dot. Okay, and this is equal to 1, so I will get e. And can you see actually I can shift the minus 1 over to the other side. So when I shift it over to the other side, let me just rewrite this again. So I'll get this pi over 4 cubed over 2 plus 1. So this will be my final expression that I need to find. And since the question did not ask for any exact value, estimate, so probably I can just use my calculator to evaluate this expression here. And you should be able to get a value of 2.34 to 3 SF. Okay, so that it will be my part C of the question.